Here is a little video description of some of the problems in detail from the homework on 3.7 and 3.8. So the first one I'm going to start with is number 20. This is 3 equals absolute value of n plus 2. And note, I have just some little notes here that for absolute value equations, those are the only ones where you need those two cases. The first case is you set the stuff equal just the regular number. Like, so that's why I set the n plus 2, which is the stuff inside the absolute values. That's why I set it equal to 3. And then I set the stuff inside equal to the negative version. And then you just solve as normal. Get the n by itself. You get 1 in this case. You get -5 in this case. And that's why your answers are 1 or -5. So it's when you have absolute value equations, you're going to have that or some of the time. And by the way, another case where you're going to have the or. So yes, if it's like absolute value equal to something, but also if the absolute value is greater than something, that's when you have that or you could write a union symbol instead of an or. When you have the and case, the intersection, you're going to have a this and that, but what will happen is the two things will overlap, and they'll come out to one compound equality. So I'll show you an example of that a little bit later. But the answers are -5 or +1, and I put that in set notation or I put it in two separate equations. You could really do either, but just be able to recognize both and know how to use both. For number 26, here's the thing. You do the same thing. You set the stuff in the absolute value equal to a positive and negative case. But here's the problem. Before you go doing that, get the absolute values by themselves, okay? But see how this +6 is hanging out? Move the 6 over. That becomes a -4. And now you do your two cases. Now notice how the thing over here is a -4. So from our first case, I set it equal, the stuff inside equal to -4. For the second case, I set it equal to +4. Now, technically, you could have done these backwards because it's just an equal sign. But the reason I tell you that keep it the same for the first case is when you get to inequalities and you flip the inequality, it might make a difference if you do, if you're insistent on doing the positive side first and the negative side second. Really, just you keep it the same and then you switch it the other time. Solve the equation as normal, right? First, move the 2 over, then divide by the 3. And here are your answers. It's -2/3 or +2. I like to write them in order here when I do the little set notation. So this is perfectly okay to write. Really, you can write it this way too. They're both acceptable answers. This one, just use the set notation. Number 27, kind of the same scenario. Before you start doing the two cases, get the absolute values by themselves. This equation looks more complicated than it is. It's like, oh, there's so much stuff. You got the absolute values. It's multiplying by 4. You're subtracting 1. Well, just move that stuff over, right? Add the 1, divide by 4. And then now you have an absolute value equation equal to a number, which is just like the first one was. So we set the two cases, set it equal to the positive and negative version, solve as normal. And your answers are 3 or 0. And here, actually, I kind of goofed. It's not that it's necessarily wrong, but this is not really the best practice. I put the 3 first before the 0. Technically, I should put the 0 and then the 3 because I like to put them in ascending order from small to big. So that's just something I kind of messed up on. What it does, it helps you keep track of things. It helps you keep things in order. That's why you want to go from small to big. It's good to have a system for that. Notice that these are not ordered pairs. It's not 3, 0 or 0, 3. It's not a point on a coordinate plane or anything. It's literally the answers are 3 and 0. All right, I'm going to go on to number 53 from 3.7. Very similar to the last one. Move the 6 over, divide by 3. Then you set your two cases, right? And notice how when I went to write my cases originally here, I was like, oh wait, I wrote my absolute value signs, and I thought, you know what, this is a good idea to kind of keep in. Um, it's you don't have to put your absolute value signs anymore once you start making the two cases. So I scratched them out and I rewrote it as, wait, no, just remember you don't need to put those. You solve the equation as normal. Move the 7 over by adding it because it's -7. You do the opposite. You do those inverse properties, divide by 5. All right, and then here's the thing. You're going to get some fractions sometimes. So 17 fifths or -3 fifths. I like to put the -3 fifths first if I do it in set notation. I like to put the 17 fifths later if I do it in set notation because that's the bigger number. You could write, this comes out to like -0.6 as a decimal. You can write them as decimals, that's fine. because these are like non-repeating decimals, so they're really clean decimals. You could write this in decimal form too. You could also write it in mixed number notation. This would be 5 and 2/5 if you did it as a mixed number, but improper fractions are fine. They're easy to work with, so it's fine to put your answer like that, but be able to recognize it in any form. Number 76, okay? So first, I answered the question. It was talking about, so we had this fence. If you refer back in text, but there's this fence. We want it to be 5 feet high, but the ground can be like give or take 3 inches. Well, here's the idea. You're going to want your fence at its highest, like it's going to be 5 foot 3 inches. Like when it says, you got an error of 3 inches or give or take 3 inches. Well, you could add 3 inches in one scenario, so 5 foot 3 inches, or 4 foot 9 inches. This would be the scenario if you subtracted the 3 inches, okay? And we talked about situations like that in class. If you want to force the algebra into this, it's the idea is that the difference between the height of the fence and the 5 inches is going to be 3 inches in one direction or another. The absolute value equation ensures that, well, maybe it's more than 3 inches, maybe it's less than 3 inches. And here I did it exactly as the word problem kind of dictated, with this feet, this in inches. And just to show you, when you turn it into an equation, you don't really necessarily want these units, so you wouldn't really have this word inches, these inches units. But the reason why I went from 5 to 70 here, just in case you're curious, wait a minute, where's the 70 comes from? Well, I converted from feet to inches. 5 times 12, I hope it's 70. Oh, wait, you know what? 5 times 12, I'm realizing that is 60. So that should actually be a 60 right here if you did it this way. So the little mistake there. So just catching that now. Let's go up to, now we're going to the next section, 3.8. That's over on this side. So they want us to do some intersections with these sets. All right, so I wrote the sets right here just to have them as a reference. I like to stack them on top of each other. Now, B, they didn't actually give the set numbers. They just said they are even whole numbers that are less than 9. But those are 0, 2, 4, 6, 8. It's a good idea that if they give you a description of the set in words, write it in numbers so that you can really visualize it. Now, let's look at only A and B matter for the first one. So A intersection B, it has to be in both A and B. Can't just be in one, can't just be in the other. Notice that number 4 is the only number that's in both. Therefore, it's in the intersection. So 4 is the intersection of A and B. Similarly, look at B and D. Now, only B and D matter. Okay, so B is 0, 2, 4, 6, 8. D is 1, 3, 5, 7, 9. Well, if you look at, oh, wait, you know what? I may have made a mistake here. I wrote B and C. So actually, the intersection for number 20 for B and D, since this is only even numbers, this is only odd numbers, the intersections actually be the null set. So I'll have to correct that. This is going to be like literally a little circle with a line through it. So that's the answer for number 20. I'll update that on Moodle. Here for number 24, they gave you those really generic descriptions about these 3 different sets, and you got to like intersect them, and you have to form the unions and all that. This is what it looks like. Basically, what I did. Here's a good practice for this. If you ever have to do this, start with the set that has the fewest elements. See if it has that element C. I want to see if, oh, hey, look, that element C is also an L. So I knew to write it between C and L, but it wasn't in M, so I didn't have to write it. In fact, none of these elements are in all 3. If there was an element in all 3, it would be right here in the dead center. All right, in that almost triangle shaped thing, not quite a triangle, kind of a curvy triangle. Kind of looks like a guitar pick. All right, but none of these elements are in all 3, but C and 3 are in, L and N. Duck and triangle are in M and N. You can see I kind of circle them there. A, horse, the number 2, cow. Those are only in L and in nothing else, so that's why I write them right here. This is the only L section. B, the number 1, and pig are in both M and L, but they're not in N, so that's why we put them in this section. And then negative 1, 0, and Y are only in M. All right, now let's look at one of the last inequalities. All right, so looking at number 27 here. So it's an absolute value equation, but it's an inequality. Now, this is the one where I told you if it's a less than, absolute value equation less than, then it's going to be that kind of and or intersection. And here's why. We have two cases. We still split up into two cases, the positive version and the negative version. But here's the idea. Anytime you do it with inequalities, when you do the negative case, you also flip the inequality. We solve the equation as usual. Now we want something that's less than 19 thirds, but also greater than -3. Well, what does that mean if you're bigger than one number than less than another one? That means you're in between them. And so that means this is your answer. So -3 is less than x is less than 19 thirds. That's a weird way to read this, though. Really, we read this as x is greater than -3, x is less than -19 thirds. Or if you try to really how you read it in English, x is between a -3 and a 19 thirds. But it doesn't include -3 or 19 thirds because it's not less than or equal to. It's just strictly less than for these symbols. So it's just between these two numbers. But notice that when there's a less than symbol after an absolute value, you're going to have that and case. Now there would be an or case if there were a greater than symbol right here. Then you'd have an or case. So let's look at the last one that was requested was number 38 here. So let's look at number 38. So number 38 was asking about this set. It seemed a little weird at first. It tells you, okay, there's a survey. 22 of them like tennis, 25 like football, 17 liked tennis and football. And here's the thing, this could get a little confusing. You might think, okay, when I draw a Venn diagram of this thing, let me look at this thing as a whole. So let's look at the people who liked. So I know 22 people like tennis. You might think the people who like tennis and football, if you look at this, is 17. But here's the thing, the 17 is the people who like tennis and football, but it doesn't exclude the people who maybe also like baseball. So the reason why the first question, the ones that like only tennis and football, well, there's 6 people who like all three. So we want only tennis and football. So don't include the people who like baseball, tennis, and like and football. So you basically subtract the 6 from that 17 from the in this case, let's see, this number right here is that's a 9. So you subtract that 6 from the 9 and that's why you get 3. Okay, and then here there was the 17 that like tennis and baseball is right here, but this also includes the people who like tennis and baseball, and then this part is the football. They like football also, but they want just tennis and baseball. So you exclude the people who like football as well as those two. So the ones that only like tennis and football, but not baseball, 17 minus 6 is 11. Similarly, the people who like football and baseball, but not tennis, take away that 6. Originally, it was a 20 that like football and baseball, and then some of those liked tennis 2. Take away that 6, you get 14. So the answer to those questions are 3, 11, and 14. All right, I hope that helps, and I'll remember I'll update. I'll change those answers for number 20, which should be null set. And there's these are kind of these two are out of order. It's not a big deal, but yeah, I'll fix it. Thanks for watching.